In this video, I'm going to be going over exactly how to do dimensional analysis. So dimensional analysis is a way of converting between units that are non-metric units, typically. So when you are converting metric units, it's a lot easier because typically you just have to move the decimal place. But sometimes you are trying to convert between two units that are not necessarily metric. And in that case, you have to use a process called dimensional analysis. So in order to do dimensional analysis, there are a couple things to keep in mind. First, conversion factors are going to be what you use to change from the original units of the number to the desired units that you're trying to get. So for example, if a question is asking me to convert 17 inches into miles, the inches would be the original units and miles would be the desired units. Units will cancel out if they appear on the top and on the bottom of the problem's setup. So in order to get a unit to go away, it needs to appear once on the top and then also once on the bottom. If it's on the top and on the bottom, it cancels out. And the ultimate goal is that all units should be canceled out in the end, except for the desired unit, the unit you're trying to obtain. So what is a conversion factor? So a conversion factor is just, it tells you the relationship between two units. You probably already know a lot of conversion factors just off the top of your head. So one example of a conversion factor would be 12 inches is equal to 1 foot. That's the relationship between inches and feet. And I know that something that is 12 inches long is also going to be 1 foot long. It is the same amount of length. You also might know a few others. So for example, 60 minutes in an hour. It's telling you the relationship between those two units. And I know 60 minutes is the same amount of time as 1 hour. Those two things are equivalent. So it's talking about the same amount. It's just measured in two different units. So by writing it this way, you can say the relationship between two units. Conversion factors are going to be what we use to actually set up these problems. All right, the first problem I want to do is a time problem, and I like to start with time problems because you probably know all of the relevant conversion factors already, and in fact, this problem, convert 14,992 seconds into days, you probably could figure that out without dimensional analysis, just with a calculator, just logicking it out. However, you do need to know sort of how to set these problems up using dimensional analysis. So the first thing you want to do is write down the number that is given to you in the problem with the unit that it has. Okay. And that's going to be the start of my problem. So I need to think about a way to go from seconds to days. So the first thing I could do is change seconds into minutes because I know there are 60 seconds in 1 minute. So that will be the first conversion factor that I will use in this problem. I can also change minutes into hours. And then I can change hours into days. So by writing these three conversion factors, you can see I have a path to go from seconds to days. I can change my starting unit, seconds, into minutes, then I can change minutes into hours, and then I can change hours into days. So there is a path to go from seconds to days. So let me move this down so I have more room for my actual problem. All right, so the first thing that you want to do is set up your dimensional analysis. And there are several ways that teachers like to do this. Personally, I like to use boxes. Some teachers like to use fractions instead, and they'll both give you the same answer, so it doesn't really matter which way you set it up. All right, so the first step to go from seconds to days is to change seconds into minutes. And I know from below that 60 seconds is equal to 1 minute. I know that I need seconds to cancel out. That is the unit that needs to go away. And the units will cancel out if it is on the top and on the bottom. So to get seconds to cancel out, I'm going to put it down here. And minutes will go on the other side. There are 60 seconds in 1 minute. So you can see here how these two units match. That means that seconds is going to cancel out. And in fact, I'm just going to go ahead and put a line through it to show that it is canceled out. All right, the next thing I have to do, I have to continue the problem. If I were to stop here, I would change seconds into minutes, but I want seconds to be in days. So I'm going to keep going. The next part of the problem, I have to change minutes into hours. And I know that there are 60 minutes in 1 hour. So you can see here, minutes is on the top and it's on the bottom. So minutes is going to cancel out. If I were to stop here, I would have successfully changed seconds into hours. So I have one more step, and that is to change hours into days. I know hours has to go on the bottom, and that there are 24 hours in 1 day. Okay, so hours is going to cancel out, and so days is going to be the only thing that is left. So if I set up the problem just like this, I will successfully change seconds into days. So how do I put this in my calculator? So anytime you have a number that is on the bottom of a fraction, like that 60, you're going to divide by that number. And anytime you have a number on the top of a fraction, you multiply by that number. So I'm going to start with 14,992. And you don't have to write this out separately. I'm just showing you. You're going to divide by 60, divide by 60 again, and then divide by 24. And the reason we're dividing for all of these is because all of those numbers are on the bottom. Anytime there is a 1 on either side of a conversion factor, like the 1 minute, 1 hour, 1 day, you can ignore that because whether you are multiplying by 1 or dividing by 1, it's not actually going to change your answer. All right, so after I plug those numbers into my calculator, 14,992 divided by 60, divided by 60, divided by 24, you get 0.17352 days. So a fraction of a day, not an entire day. It's about a little less than a fifth of a day. Okay, so that is how you would set these up. All right, next problem. This one, conversion factors are given to you. That is often going to be the case. The reason they weren't given to you in the last problem is just because a lot of those you probably already know. Now, I'm not necessarily going to use all of the conversion factors that are in that box, but I do have enough there that I can successfully solve this problem. So in this problem, I'm trying to change 0.512 gallons into milliliters. That's the goal. So what I'm going to do before I start actually setting up the problem, I'm going to sort of map out how I'm going to do this. So I know looking at this box, one thing I can do is change gallons into quarts. After that, I actually have two options. I can either change quarts into pints, or I can change quarts into liters. So I have a decision to make, and you have to use your reasoning. Which will get me closer to milliliters? If I change quarts into liters, or if I change quarts into pints. And the answer, of course, is if you change quarts into liters, it is going to be easier to go from liters to milliliters. So I'm going to change gallons to quarts first, and then I'm going to change quarts to liters, and then I can change liters to milliliters. So those will be the conversion factors that I use to set this problem up. So go ahead and set up my line. I'm going to start with the number that was given to me in the problem, 0.512 gallons. First step is to change gallons into quarts, and I know gallons has to cancel out. And in the box, it says that 1 gallon is 4 quarts. So if I'm looking at my units, I can see gallons is on the top and the bottom, so gallons is going to cancel out. Next, I'm in quarts, so the next step is going to be to change from quarts to liters. And I know from the box that 1 liter is 1.057 quarts. So quarts will cancel out, and that'll leave me in liters. And then finally, the last step is to change liters to milliliters. And the box also tells me that 1 liter is 1,000 milliliters. That one is actually a metric conversion. You can use metric conversion factors in dimensional analysis. And in a problem like this, that would actually kind of make sense, because if you're already doing dimensional analysis to go from gallons to liters, you might as well just add on one more conversion factor to change it to milliliters instead. All right, so for this one, to plug this into my calculator, here's how I'm going to do it, 0.512. Next to that, oops, I forgot to cross off liters. Next to that, it says 4 quarts over 1 gallon. The 4 is in the top, so I'm going to multiply by 4. Then the next fraction, the 1.057 is in the bottom, so I'm going to divide by that number. And then the 1,000 is in the top, so I will multiply by that number. So that is how I plug it into my calculator, 0.512 times 4 times 1, or divide by 1.057 times 1,000. And you get 1,937 and some change. So I'm going to round that to 1,940 milliliters. And that'll be my final answer. Okay. All right, let's do one more. This one is length. And again, all of the conversion factors you need are in the box, but there are some extra ones in there too. So this says convert 23,901 centimeters into miles. So in this problem, I'm starting with centimeters and I'm trying to go to miles. So if I look in my boxes to try to come up with a way to change centimeters to miles, I have several options to start with. I could start here and change centimeters into inches. Centimeters is also over here, so I could change centimeters into meters. But if I'm just using the conversion factors in the box, meters is not necessarily going to get me to miles. So I could change it to meters, but then I would have to change meters into kilometers, and then I'd be stuck. I would have no way to go from kilometers to miles. If you knew how many kilometers were in a mile, you could go that route. However, that's not in my table, so I am going to try a different way. So I could change centimeters into inches first. Once I change inches or centimeters into inches, I could change inches into feet, then feet into miles. And that'll get me from centimeters to miles. Okay, so start with the number that is given to you in the problem, 23,901 centimeters. I know I have to change centimeters to inches first. Centimeters is the unit that needs to cancel out, so it goes on the bottom. Inches is what I'm changing into, and I know there are 2.54 centimeters in 1 inch. So centimeters will cancel out. Next, I have to change inches into feet. And I know 1 foot has 12 inches. So inches will cancel out there, and that will leave me with feet. And then the last step is to change feet into miles. And I know 1 mile is 5,280 feet. So you can see feet cancels out and you're left with miles. All right, so that's the setup. That will get me from centimeters to miles, and I know that because all the units are crossed off except for miles. So to plug this in my calculator, it'll be 23,901 divided by 2.54 divided by 12, and then divided by 5,280. This one will be division all the way across because all of the non-1 numbers are in the bottom. So let's see, 23,901 divided by 2.54 divided by 12 divided by 5,280 is 0.14851 miles. And that would be the final answer. So that is how you set up problems with dimensional analysis. You just sort of have to logic out what the path is to go from your starting unit to your ending unit. And if you have the right conversions, you just have to make sure that your units cancel out correctly. It takes a little bit of practice, so go ahead and try the practice on Canvas. Check your answers, make sure you're getting it, and let me know if you have any questions. Bye.